Hello everyone, my name is Vamsi and my project partner is Parinita. We are here to discuss about our machine learning project called Twitter account bot or not. So why is it required to find whether the Twitter account is maintained by a bot or a human? While many bot accounts can be harmless, most of the bots are created with the intention of making a nuisance, posting unwanted stuff over the internet and offending normal people. So our aim is to differentiate the accounts maintained by humans and bots. So when a new account is given, our classifier predicts if it's a bot or not. We have used Twitter API to download the dataset which consisted of 3,400 entries, out of which 2,800 are used for training the classifier. This is a sample of our dataset. You can observe features like screen name, description, followers count, status, bot, location, and many others. You can observe the unclean data in description fields, created at field, status field, etc. So we need to pre-process the data before going to train our classifier with this. In the pre-processing part, we need to deal with missing values, categorical features, and text fields. For missing values in numeric fields, none values were replaced with 0. In Boolean fields, none values were replaced with the mode value of that field, which is usually false. For categorical features, we use label encoder class from scikit-learn, which will transform the words to numericals. To deal with text data in screen name, name, and description fields, we used a package called regular expressions. We searched for the word bot in those fields and replaced them with 1 if the word was found. It can be observed that bots tend to have younger accounts as compared to human accounts. Also from the dataset, it can be seen that even newer bot accounts have a significant number of status counts, almost comparable to older human accounts. To take advantage of these facts, we found the average number of tweets an account has made since its creation. For this, we found the number of days since the account was created and the current date. The status count was then divided by the number of days to get the ratio of average number of tweets for an account per day. This was one of the features used to train our model.
Training the machine learning model. In order to train a machine learning model and check its accuracy, we split the data set, that is the original training data set, into a training and test set. We assigned 80% of the original data set to be used as the training set, while the rest 20% to be used as the test set. The performance estimation for a model was done using the accuracy score and the k-fold cross-validation score, in which the dataset is split into k consecutive folds and each fold is then used once as a validation while the remaining folds form the training set. Models used. The algorithms used to train a data set is random forest and decision tree. Decision tree constructs a decision tree using the information gain and forms the level of the tree where the leaf is labeled with the predictive class. The random forest fits a number of decision tree classifiers use on various samples of the subset and uses averaging to improve the predictive accuracy. Feature selection and accuracy. To improve our accuracy, we selected different features at different attempts. One such selection can be seen on the slide here, where we selected many features, approximately 13 features, which yielded high accuracy for both the algorithms on the training set, like 98% for random forest and 96% for decision tree, but the actual accuracy was really low. It was due to overfitting. It was approximately 68%. So selecting too many features to train the model usually results in overfitting and lesser accuracy. Another set of selected features can be seen on this slide here, which didn't include the default profile image, and the has extended profile. It did yield better accuracy score than the previous feature selection. Our actual accuracy score actually improved to 96%. On this slide is another feature selection that includes the name feature along with the screen name and description features. This yielded similar accuracy to the previous one, and our highest accuracy score that we have obtained is approximately equal to 96%. In conclusion, I would like to say that while training a model using different features, we found that selecting too many features led to overfitting and resulted in less accuracy. Also, random forest algorithm gave better predictive results than decision tree algorithm, as it is better at controlling overfitting than decision tree is. Thank you so much.